Hello everyone, I'm Riccardo Spolaor. I'm going to present to you Can't You Hear Me Knocking, or Identification of User Action on Android Apps via Traffic Analysis. This work started as a master thesis project, and then I graduated in April. And then we obtained so promising results that we decided to keep going on working on this topic. The author of this project was also Mauro Conti from University of Padua, Professor Luigi Mancini from Sapienza University of Rome, and also Nino Verde, always in the Sapienza University of Rome. So the outline of this presentation is the brief introduction about the motivation and the contribution of our work, then some related work to ours, and then the explanation of each component of the framework that recognizes the user action, and then we evaluate the performance obtained with our solution against the other method in the literature. Finally, we draw some conclusion and some future works. So first of all, the motivation of our project is: how are we able to recognize user action that a user performs with an application in his smartphone? And basically, our project is an attack to the privacy of the user. And we demonstrate as our contribution that this is possible, and we obtain an accuracy higher than 95% in user action recognition. How we do that? We use machine learning techniques to recognize this specific action. Okay. So, some related works to ours. The first example is Who Do You Think You Are, presented by Stober in WISEC, that recognizes a set of applications installed on the smartphone device, simply analyzing the traffic burst of the synchronization services, that the apps produce in background. Another one is Touching from the Distance, presented by Kai in CCS. It's basically a website fingerprinting through encrypted traffic analysis. So also, if the traffic, despite the traffic is encrypted, they was able to recognize the web page the user was browsing. Another one, more related to ours, is Identity, Location, Disease, and More, Inferring Your Secret from Android Public Resources, presented by Zoo. It's always in CCS. But they, in particular, they focus only on the recognition of only one specific user action for Twitter, and in particular the action of produce a tweet from the device. Another one related to our works is a network profiler, but this work needs a payload analysis, a deep payload analysis on HTTP request and response. So they cannot perform their analysis in encrypted network traffic. And why we need the encrypted network traffic analysis on our solution? Because the distribution of the protocol on the packet capture in our project was the 95% for TLS version 1, and basically is encrypted traffic, and negligible amount of other kind of protocol. So basically, every packet in the application we consider for our analysis was encrypted. So a deep inspection of HTTP packets was not feasible. So how could I exploit the timing of user action to attack the user privacy? Basically, we present some possible attack scenario, and the first one is user recognition. Then we assume censorship government, like a big brother, and then the eavesdropper. So the first example, there are a lot of user recognition system in the literature, where from the network traffic of a user, we can be able to recognize an individual user among all the other. And using the knowledge about the timing and the precise user action a user perform, we can boost up as a building block the user recognition system in order to achieve a more higher accuracy. Another possible attack is on social network. Let's assume there is an anonymous user who want to remain anonymous. And if some powerful attacker, like the government, could assess the knowledge of the precise user action a user do with this smartphone, it can correlate them with the public post, and then the government can recognize that the user is the specific user of the phone. So this is a basic example of identity disclosure. Another one, from the traffic, I can identify where an action is done, when an action is done, and some malicious eavesdropper could focus on a particular action, so in a particular portion of traffic, and try to decrypt it to steal the password of the user, instead of consider all the traffic produced by the smartphone. So the two key concepts to understand the rest of the presentation are two. One is the user action. With the term user action, we consider the operation the user perform with the apps. For example, with Gmail, the user can send or receive or also reply to an email, while for Facebook, the user can post something on his wall or in a friend wall. But this user action produce network flow. So we consider a network flow as a sequence of packets in common the couple of IP address and ports among two parts involved. One is the smartphone and the other is the service. So the overview of our frameworks, we can see the data acquisition part, and then the flow building, the network flow building, and then the flow clustering, and then the very classification of user action. In our project, we consider Twitter, Facebook, and Gmail as an example of to evaluate our solution and evaluate the performance. So we set up an hardware environment to collect the traffic of a smartphone and produce the user actions automatically on this phone. In the first part, we can see a Python script that uses Android debug bridge to control the phone and let him perform the user action we need. And in the meanwhile, we can monitor the traffic produced by the phone through an access point connected with a network bridge through the internet, and we perform the capture of the network traffic using Wireshark on that network bridge. So every communication produced by the smartphone is captured by Wireshark. So basically, a Python script we use basically is a sequence of user action that explore the mobile app functionality. And also we produce a log of action with the relative timestamp for every user action performed. And then we use Wireshark, but the log file from the Python script and the capture from Wireshark have to be synchronized together through an NTP server. So to build a flow that is a basic entity of our analysis, we have to do first a packet filtering through a domain recognition. For example, if I run Facebook, I don't want to include also Gmail or Twitter traffic, maybe produced by the application in background. But I just want to see Facebook traffic. And also we discard also connection control packet, for example, the three-way handshake or the hack produced on the as a confirmation over the receiving of the packet from both sides. And then we produce a flow using the condition previously explained. So the consecutive packets with the same IP address and the same port are considered in the flow. But we trunk a flow after 4.5 seconds of inactivity, as proposed in Stober in WISEC. So in our framework, we represent flow as a time series with the packet incoming with the plus and the outgoing with the minus. And another representation very useful to understand the difference between flows is this one, where we can see the different shape for each flows, and so we can understand that these flows can be categorized by their similarity with the machine learning techniques, and we use the cluster, more particular the hierarchical cluster, to categorize the flows in clusters. So the training phase of our solution is as I said before, the clustering or an unsupervised machine learning techniques that cluster together similar flows using a particular metric to understand if a flow is similar or different to another one. And this particular sequence alignation method is called dynamic time warping, as is used also on speech recognition. Then the training, we build a training set that will be used on classification, using the user action as classes and the cluster labels as feature. So, building this training set, we can feed it to a supervised machine learning techniques or the classifier, and we use for this particular point the random forest classifier. Then the evaluation phase, we use the unseen flows as a tester to test our solution, and the unseen flows are associated with a cluster by the similarity with that cluster, and then test set will be built, and then we can perform the actual user action recognition using the previously trained classifier. Among all the user action we simulated, we consider only the one specifically related to the user privacy. For example, for Facebook, we consider the post of a status or the send of a private message, while in Gmail, we consider the send of an email or the reply of an email. On the other hand, for Twitter, we consider the publish of a tweet or the direct message, or also the opening the contact page. It could be related to privacy. The other actions that are not related too much with the privacy, we don't throw them away, but we consider them as other. So we can achieve an higher performance to our classifier. And also in other, as a bogus class, we include also the background traffic to make it distinguishable from the actual user action we are interested on. Another parameter we have to tune is the number of cluster, because the hierarchical cluster supposed to have a cutoff in the number of cluster, and the more the cluster are, the less precision we have. So we produce this kind of graph to understand which is the best cutoff for our application. For example, for Twitter, we can have a cutoff on 50 cluster, obtaining a very high result, very high accuracy, while for Gmail, we need a higher number of cluster to obtain a higher precision. So using that particular parameter on the cutoff, the hierarchical clustering, we select the best one, and we can see from this graph the F measure as a metric of accuracy. We can see the accuracy of the specific user action we consider for Facebook, Gmail, and Twitter app. And for Facebook, we achieve more than 95% of precision, while in Gmail we obtain results higher than 90%, despite this particular action or open chat that was replaced by Hangout. But for Twitter, we achieve very high accuracy, higher than 95%. Is very high accuracy. In addition to this work, we consider also other methods not particularly made for our purpose, but for web page identification. And the first one is multinomial naive Bayes from Herman. And then the other two is normal naive Bayes classifier from Liberatore and Levin. And another method proposed always by Liberatore using Jacquard coefficient. And from this graph, we can see that our method, our solution, outperform in every case the other method in literature. For example, for Facebook, we achieve an average F measure of 99%, while the best one is multinomial naive Bayes from Herman. But the other two are not achieve very high precision. They are stuck in the 70%. And also for the other two applications considered. So we draw some conclusion. So basically, we propose some framework that could permit an eavesdropper to recognize the user action performed by an user with his Android app. And this tool could be used to undermine the privacy of a user and also to identify a relationship, to disclose a relationship or the identity of the specific user. And this work basically is done to stimulate the researcher to propose a valuable countermeasure to avoid this kind of attack. Some possible future work we have in mind are to investigate more action and more app, for example, WhatsApp and Skype for Android, but also consider the same analysis on another operative system or iOS, and also consider the passive action, not action related to the activity of a user, but also related to the third party or the other user, for example, the receiving an email or the notification for Facebook or Twitter. So thank you for your attention. If you have any question.
Whether this can be used and how.
So the question is whether this can be used for forensics. So basically, if we can if we know that the user actions are performed by a user, we can determine it also with we can correlate with the public post. For example, this example is for Facebook. We can correlate the action with the actual public post, okay? And sometimes in the post there is also the location of the user. So we can understand where the post was performed by the user. So we can trace the movement of the user, and also if we can identify also the action that cannot be seen in the Facebook page, we can also understand the behavior of the user. So if someone steals the phone to do some malicious thing, I can identify if the user is actually him or is a thief. Okay. So this is an example.
Another question? Okay, maybe you can take the chance to do a call for volunteers if they want to participate in the
Okay. If you want to participate on real-life experiment, so let your phone be monitored while you perform some user action, you're welcome, and all the privacy-related stuff will be monitored and not disclosure to anyone outside this experiment. So I guarantee to.
Very short time experiment.
Yes, but
not violating your own.
Yes, another thing is we cannot see the content of a post or a content of an email, but we can see only that the mail is actually sent. So don't be afraid. We only know that that email has been sent, and then we log it.